In today's video we're going to answer the question, what is a black hole? A question that has kept scientists puzzled for decades. If you want to find out more, then stay tuned. Black holes are one of the most fascinating objects in the universe. They can be incredibly massive, yet invisible. They can also be extremely small, yet incredibly powerful. So what exactly are they? The first part of the question is easy to answer. A black hole is a region in space with a gravitational pull so strong that not even light can escape its grasp. This creates a boundary known as the event horizon, which marks the point of no return for anything that ventures too close. Once something crosses the event horizon, it is pulled towards the center of the black hole, where all the matter is crushed together in an infinitely dense core called the singularity. But how do these mysterious objects come into existence? The answer lies in the life cycle of a star. Stars are born when large clouds of gas and dust collapse under their own gravity. As the cloud collapses, it forms a spinning disk with a growing hot core. When the core reaches a critical temperature and pressure, nuclear fusion begins. Hydrogen atoms are fused together to form helium, releasing tremendous amounts of energy and giving birth to a new star. This process of nuclear fusion continues throughout the star's life, balancing the inward pull of gravity with the outward push of nuclear fusion. But all stars have a limited lifespan. When the star runs out of hydrogen fuel, the balance is broken and the star collapses under the force of its own gravity. The core shrinks and heats up, causing the outer layers of the star to expand and cool. This creates a giant red giant. The size of this red giant depends on the mass of the star. For example, our Sun will become a red giant about 5 billion years from now, engulfing Mercury, Venus, and possibly Earth. However, if the star is massive enough, say 20 times the mass of our Sun, the core will continue to heat up until it reaches a temperature of 100 million degrees Celsius. At this point, the star has become a blue giant and is emitting huge amounts of ultraviolet radiation. The radiation pressure from the star pushes the outer layers away, creating a large nebula. If the star is massive enough, this process will blow the star's entire atmosphere into space, leaving behind only a small dense core. This core will continue to collapse under the force of its own gravity until it becomes a black hole. So the size of a black hole depends on the mass of the star it was born from. For example, a star with 10 times the mass of our Sun will form a black hole with a radius of about 3 kilometers. On the other hand, a star with 100 times the mass of our Sun will form a black hole with a radius of about 30 kilometers. Once a black hole is formed, it will continue to grow by consuming matter from its surroundings. As matter falls into the black hole, it will spin faster and faster until it reaches the speed of light at the event horizon. At this point, the black hole will emit a huge burst of energy in the form of Hawking radiation. This radiation will have a temperature that depends on the size of the black hole. The smaller the black hole, the hotter the radiation. As the black hole continues to consume matter, it will eventually reach a size where it can no longer radiate effectively. At this point, the black hole will stop growing and begin to cool. Eventually, the black hole will become so cold that it will no longer be able to emit any significant amount of radiation and will essentially be invisible. So you see, black holes are not just some mysterious objects that we can't understand. They are a natural phenomenon that occurs in space. While they may seem scary and dangerous, they are actually an important part of the universe that helps to form and shape the world around us. If you enjoyed this video, don't forget to like, subscribe, and share for more videos like this. Thanks for watching, and I'll see you next time.